lab. I've been here since 1993. Most of the research that I do is in fire behavior. And so fire behavior is about how fast fires spread, how much energy they release, how to predict that kind of thing, how to train fire management people in understanding physical processes that go on, okay? And so I'm going to give you a little bit of a history lesson for about 10 minutes, 15 minutes, and then turn it over to Dr. Matt Moody, who is a research mechanical engineer here, and he's going to talk about a demonstration of an experiment he's working on here, okay? So you are sitting here in what we call the combustion chamber, or the burn chamber, and this chamber is where we do a lot of experiments that don't involve controlling the wind. So we have a tilting table here, we have lots of other apparatus tucked into corners that we bring out for experiments, but nothing in this room is involved with controlling the airflow, okay? Just it's a nice big area that we can do things. Even now though, it's pretty small, right? This was created in 1960. In fact, the lab was dedicated almost exactly 65 years ago this month. September 12th, I just looked it up. September 12th, 1960 is when this lab was dedicated, so 65 years. And if you want to read in detail about the fire lab and the history here, or the Forest Service research, there are 2 publications that are available online. There's a few of these sitting out in the foyer for you to pick up, but they're all online. You can look up the history of Forest Service research in the lab. So I'll just summarize some of that information. Forest Service research started in 1908. Forest Service, you know, the Transfer Act in 1905 moved lands from the interior into agriculture. Gifford Pinchot was the first chief forester. And it immediately became clear that they needed to have a scientific basis to do Forest Service work and manage all these diverse ecosystems and for forest products and other things. So in 1908, they established some research facilities, various places around the country. But fire research was always one of the topics that people were interested in. And for various reasons, a lot of it was fire control, and still is. But the big catalyzing event that began the interest in fire research in a bigger way in the Forest Service was the 1910 fires, right? And everybody here kind of knows that backstory. I don't have to go into it too much, but 3 million acres burned on the Idaho-Montana divide in 1910, August 20th and 21st, and killed 87 people, I think. And that was a big deal, a very big deal for the Forest Service, because we were right at a turning point, a fork in the road, if you will. Were we going to encourage more fire on the landscape, as Indians had done for a long time, and a lot of people had advocated, were we going to turn more towards fire control and fire prevention? And we took the latter path for the most part. But you know what the major cause of the fires in 1910 were? Anybody have a guess? Not lightning. Railroads. You got it. 60% of all the fires were caused by all the railroads that had just been put in a couple of years before. So the Milwaukee Road and the Northern Pacific, and there's still slash all along the tracks, and they were burning wood in the engines, and fires would get out along those tracks. So this wasn't like some big natural event. This was all due to settlement. And it was one of the last big settlement era fires throughout the country, right? The Great Lake states and up in Canada, lots of big settlement era fires, and this was one of the last ones. But it was a turning point for the Forest Service. Fire research became a big deal, and by 1922, the first full-time staff for fire research was located here in Missoula, Montana, which was the winter headquarters for Priest River Experimental Forest up in northern Idaho. And Harry Gisborne was the individual responsible for research. He was the first full-time one in 1922. Okay, and so at the time they were starting with nothing. They had to figure out, you know, weather and fuel conditions and how are all these things related to things that they could put into management plans and management actions. They started with nothing. So they started investigating a lot of weather, how to forecast weather events, what fuel moisture meant for fire occurrence and fire records. They kept a lot of details on fire records, trying to see if there were patterns in there that they could understand. But a lot of the basics they established that we still use today, like fuel moisture, right? Fuel moisture is a really important thing, and they had to come up with ways to measure that and to have it so that the field could measure it, not just in a scientific way. Okay, so they're in fire spotting. So how can we identify forest fires from lookouts? You know, triangulate on them and to be able to report those locations so firefighters could get there. So there was a tremendous number of things that they did in the early days. And I'm not going to go into all that in great detail here. But another major event that really changed fire research in the country, and still today, and it's the reason that this fire lab exists, the most proximal reason that this fire lab exists, was the Man Gulch fire in 1949. So 13 firefighters from the Smoke Jumper Base were dropped into a fire over by Helena, and they never made it out. They were 5 minutes, so they never made it out. They were overrun by the fire and killed. And indeed, Harry Gisborne, the leader of fire research here in Missoula, was hiking around on that fire afterwards to try to understand what happened, and he died of a heart attack right on that fire. So interesting story, but his protege, Barrows, Jack Barrows, was an advocate for having more formalized laboratory facilities for investigating fire. And 1957, they visited our congressional staff, they visited our senators and our congressmen, and they lobbied for a facility just like this. Well, you know the way that kind of thing goes in Congress, it kind of languishes for a little while, 1957. But there was another incident that caused a lot of interest, renewed interest in investing in science and technology, and that was Sputnik in October of that same year. And so Congress acted, and they appropriated the funds, and this laboratory was designed and built within a couple of years and opened in 1960. And then they staffed it up, and there was a number of different research projects that they wanted to focus on. One is fire behavior, and that's still what we're doing today, what Matt's going to talk about, and what I'll talk about later in the wind tunnels. There was fire danger rating is a big thing, because at the time they didn't have a way to incorporate a lot of the all the environmental factors into understanding fire business. How much fire business are we going to have? How are we going to staff? Where are we going to put various resources? So fire danger rating was a big deal. Fire weather was a big thing. At the time they thought that they were going to be able to do cloud seeding and put out fires with that. So they tried that for a while. Fire mapping, which is still being used, infrared fire mapping. A lot that was initiated here. So fire retardant use, which is still something that is being investigated to some extent. So a lot of those programs that they started are still going today. And we still need these facilities even more now because the problems we have with fire are way past anything was envisioned in the 1950s or the 40s, okay? And yet we have fewer facilities. This is the last fire research lab in the country that's still standing. We had one in Riverside, and we had one in Macon, Georgia, and they're all closed now. So you're in the last one. You know, makes you wonder why we don't invest in fire research more now that we have more fire problems and more need for the science. So I'm probably going to run out of time, but so I will end it there and ask if there's a few brief questions before we transition over to Matt's presentation. Any questions?
So, Mark, you talked about those initial programs and how they're more relevant. Is there maybe some of the top ones that you're looking at today that seem to, you know, create these big differences in these catastrophic landscapes that you see a huge change in that you really want to dig into?
Yeah, that's a great question. So the sciences and the technologies that arose in the 1960s and the 70s here, we're still using today. But they made a lot of very simplifying assumptions to allow the problem to be tractable at the time. Those simplifying assumptions are what hang us up now. The fire behavior prediction and modeling systems make very simplistic assumptions about the nature of fire that we're actually calculating. It doesn't take into account long burning fuels that burn for hours and hours and generate heat from very, very large areas. Many things about those models and those prediction systems are very unrealistic, and it takes a lot of expertise to be able to adapt reality into the framework that the model can understand. So there's a strong need to update those models from the 1972, right? We're still relying entirely on the nature of fire prediction as it was conceived of in the 1960s and 70s. And so we need to go well beyond that. And so that's why these facilities are still really valuable.